igcse Physics, Paper 2, Radioactivity, Part 1. A stable nuclei can emit particles. Which of these particles has the largest alpha? Which of these particles has the largest charge? Alpha particle is the answer because it has two protons, so a positive 2 charge. The charge is 2, whereas beta is negative 1 electron, so 1, and this is neutral 0, and this is 1, so 1 0 1 2 alpha. Which of these particles has the largest mass? Alpha particle, as it has two protons and two neutrons. This is just an electron, this is one neutron, and this is one proton. The maximum range of a beta particle in air is about 50 centimeters, 50 mm, 50 centimeters, 50 meters, and 50 kilometers. The answer is 50 centimeters of a beta particle in air, the maximum range. When a nucleus emits a beta particle, the nucleon number decreases by 1, the nucleon number increases by 1, the proton number decreases by 1, or it increases by 1. So a proton number increases by 1 as a neutron turns into a proton and a electron is emitted, an electron particle. Next page. The photograph shows an old camera lens that contains several. Let's check the answers of the previous page. Alpha 50 centimeters, and proton number increases by 1. The photograph shows an old camera lens that contains several pieces of glass. One of the pieces of glass includes a radioactive isotope, thorium 232. Thorium 232 undergoes alpha decay and produces an isotope of radium. Ra. Complete the equation for this decay. So we know alpha particles have 4 and 2 is the atomic number, and 2 minus 4 is 228, and 90 minus 2 is 88. So 228 and 88. Yes, 228 and 88 and 42. Radioactive glass also emits beta particles from a different isotope. So this radioactive glass also emits a beta particle from a different isotope. A different isotope emits beta particles. The diagram shows the position of the radioactive glass in the camera. This is why it is safe to use radioactive glass in the camera as shown, because the ordinary glass and the thick aluminium will absorb the beta particles. Idea that alpha slash beta is absorbed by / unable to penetrate aluminium or the glass. Okay. Amateur astronomers sometimes remove an old camera lens, so this lens, to use as a lens in a homemade telescope. So the telescope is close to their eye, so that's why an astronomer should not use a lens with the radioactive glass close to their eye, because if the radioactive glass is close to the eye in the telescope, then the radiation will be ionizing and it can cause cancer, cell mutation, kills cells, and blindness. Alpha / beta will travel the short distance between lens and eye. This will travel the short distance between lens and eye, alpha and beta. slash beta, idea that astronomers likely to suffer prolonged exposure. Oh. Scientists use deflection in an electric field to help distinguish between different radiations. Diagram shows a beam containing several types of radiation. This beam travels in a vacuum between two charged between two charged plates. One is positive, one is negatively charged. Some of the radiations are deflected upwards, downwards, and some are not deflected at all. So let's check. Alpha is deflected deflected upwards because so it goes up because it is a positively charged particle, so positive and negative attract, and it is deflected because positive and positive repel. Beta goes is deflective downwards because it goes down as it is repelled by negatively charged plate and attracted by this plate. Gamma is not deflected as it doesn't have an overall charge. So gamma doesn't have a charge. Neutrons are uncharged and protons are positively charged. So that's why they go upwards, they are deflected upwards to the negatively charged plate. The diagram shows the apparatus Geiger and Marsden used to investigate the structure of an atom. They aimed a beam of alpha particles at a very thin sheet of gold foil. They used a zinc sulfide screen to detect the alpha particles. So this is labeled zinc is the gold foil, zinc sulfide screen, and beam of alpha particles microscope. So just why Geiger and Marsden removed the air from the apparatus. Because alpha has a small range in air, alpha particles have small range, cannot travel far in air, and alpha would not hit the gold leaf because it would be deflected, collide with the air particles molecules. Alpha would ionize the air particles slash molecules. Describe Geiger and Marsden's results. So results any two from most went straight through. The paths of a few were deflected at an acute or a small angle. The paths of very few were deflected through an obtuse angle, or they were backscattered, as in they bounced off the gold foil. So most of them went straight, and it says most went straight through, and few were deflected at an acute angle, and very few were bounced back. So as it says here, very few were back scattered, or they were deflected to an obtuse angle. So back scattered, bounced off the gold foil. So like back scattered means bounced off the gold foil. Okay. And for the next question, Rutherford produced a model of the atom. Describe how the Rutherford's model explains Geiger and Marsden's results. You may draw a diagram to help your answer. So it can be shown on a diagram. For explanations, a small nucleus, mostly empty space because not many alpha deflected because most alpha got through. So it's small because most went through and not many were like deflected. Positive or high mass nucleus which causes deflection of positive or or low mass alpha. What this answer means is, so with the small nucleus has the atom has mostly empty space around it, so it has a lot of space because the nucleus is small, so not many alpha particles are deflected and most go through. But positive or high mass nucleus that have a high positive and high mass, so they cause deflection of positive or low mass alpha. So they have they have a high mass and are positive, and they cause a deflection of alpha that are low mass. So alpha are low mass and alpha are also positive, so they are deflected in this case. Oh, and also I realized that this question in the first page, this is actually wrong. The maximum range of a beta particle in air is not about 50 centimeters. The maximum range of beta particles is actually a few meters. This is half a meter. So actually, the maximum range of beta particles is a few meters actually. So yeah, that's what I wanted to point out. For this question, in 2013, the UK government decided to build another nuclear power station where in a place where a major agricultural uh, area of the UK. So Hinkley Point is in Somerset, and that is a major agricultural area of the UK. This will be the third nuclear power station at the site. Discuss the advantages and disadvantages of nuclear power stations and biomass power stations. So the benefits of nuclear fuel: no CO2 emitted, does not contribute to global warming, reliable, not weather dependent, a small volume of waste, and also the transport costs of the actual fuel is not much as it's very concentrated in a very small amount, and the power stations are relatively small, difficult to dispose of the nuclear waste, accidents can spread radiation, fuel is toxic, harmful, and long half-life. Decommissioning costs are very high, increased security risk, terrorist attacks. And benefits of biomass are all these: abundant sources, renewable, source is relatively cheap than nuclear fuel. Uh, all these are the disadvantages. And for this next question, go for experiment. Scientists used to think that electrons were spread out through a positively charged atom. This is called the plum pudding model. To test this idea, scientists aimed alpha particles at thin gold foil. They expected the alpha particles to pass straight through. The results showed that almost all alpha particles did pass through, but a few did not. About one in every 8,000 were deflected away at a very large angle. It was these anomalous results that led to a new understanding of the atom. What was the prediction in this experiment? All alpha particles would go through the foil. They expected them to pass straight through. What do scientists mean by anomalous points results? Idea that they do not fit with the pattern or match with the trend or concur with the pattern or trend. How should scientists deal with anomalous results? Can either use them to check and repeat the measurement, the experiment again, check and repeat the experiment, work out why the anomalous results have occurred. So that's how they can use um, anomalous results by checking why they occurred in the first place and repeating the experiment. Thank you.